Okay, so we're going to move on to looking at parallel and perpendicular lines and looking at equations of parallel and perpendicular lines. But before we do that, I want to define the word parallel and the word perpendicular. What does two parallel lines mean? Anyone?
Like they're straight together.
They're straight together. Can you give me an example of two parallel lines? That's right. They're like, you know, the train tracks, right? The train tracks, they never actually meet, right? No matter which direction they're going, right? You see that they're going to be, they are parallel to each other, right? So if you take this section, these two lines, they're never going to meet. They're never going to be an end where they actually meet together, okay? So parallel lines, they're lines, we call them, so they're lines that they never meet, okay? That's what parallel means. And in order for us to determine or to identify that these are parallel lines, we usually put an arrow, okay? If I have two lines and they're parallel to each other, I put an arrow to indicate that these are two parallel lines, okay? If I have another set of parallel lines, let's say this way, right? These are two parallel lines. Again, and I want to indicate that these two are parallel because I've already used one arrow. So in this case, I'm going to use two arrows. So I'm indicating that these two lines, this set of two lines are parallel to each other. Okay? So parallel lines are lines that never meet. Now, sometimes also two lines that are overlapping, right? They're also considered parallel lines, right? But they have a special kind of equation. So we're not going to talk too much about these. Now, perpendicular lines Does anyone know what perpendicular lines are? So they are lines that meet at a 90 degree. Okay? So we call them, they're perpendicular to each other. That means they're meeting at a 90 degree. Okay? So if you think about the x and y axis, right? The x and y grid, the Cartesian plane, right? So if you have the y-axis, right, and you have the x-axis, right, they meet at 90 degrees. So we call these two perpendicular to each other, okay? This is the sign of perpendicular. So when you have that little square, right, in the corner where the angle is, that indicates 90 degrees. So I don't have to write that 90 degree, okay? That's an indication of two perpendicular lines. Okay, so if I want, let's say, if I have a line that goes like this, right, I can draw a perpendicular line to it as long as they have, I'm trying to make it 90 degree, as long as they have a 90 degree angle. Okay, again, I don't usually write 90, I just have to indicate it with a square angle. Okay, so if you think about a square, okay, what's special about a square or a rectangle? It does have both, you're right. Okay, so if I look at a rectangle in this case, I think I'm drawing. What is this, a rectangle or a square? 1, 2, 3, 4, 5, 6, 7. I think it's a rectangle. Yeah. Okay, so if you look at this, right, this line and this line, they meet at a 90 degree. Right? So this line and this line right here and this line right here, they're perpendicular to each other. Right? But at the same time, I have two sets of parallel lines. Right? What line is parallel to this line? The bottom one. Yeah? So these are parallel to each other. Okay? What line is parallel to this one? The one right there, right? So they will never meet. Okay? But again, at the same time, I can say that these two lines are perpendicular to each other, right? They're perpendicular to each other. Okay? So this is where the case I have both. I have perpendicular lines, but at the same time, I have sets of parallel lines. Are we okay with this? All right, now we're going to look at what, you know how we've been talking about equations of the line with y equal mx plus b, right? Now we're going to look at the equation of the line and we're going to see how can we tell if these lines are parallel or not. Okay? Or if these lines are perpendicular or not. Okay, here's the note. Here's what I want you guys to remember. Lines that are parallel to each other have the same slope. Now I want you to ask yourself, does that make sense? Does it make sense that they have the same slope? What does slope mean? What does the word slope mean? What does it indicate? The steepness of the line. Two parallel lines, they have to have the same steepness. Right? So, parallel lines.
No, I said my definition says rise and run.
That's right. Slope is the rise over the run. That's right. And two parallel lines have the same rise versus run. So the rise over the run is the same for both lines. So here's a question to you. I have 4 different equations of the line here. Can you spot 2 equations that show parallel lines?
Say that again, Miss?
So, which of the following equations are parallel to each other? Yeah? Which ones? Now, let's go back and read this, okay? Lines that are parallel to each other have the same slope. Can you guys tell me what the slope is in this equation? So which one indicates the slope? 5, right? Because remember, the equation of the line is y equals mx plus b, where m is the slope. Do you guys remember that? You remember that? Where m is the slope and b is the y-intercept. Oh my God. You remember that? Where we had to graph and then we had to start with a y-intercept and use the slope as my rise over run? Okay, so in this case, 5x minus 3, 5 is your slope. What's your slope in this equation? Negative 5. What's your slope in the third equation? 3, just the number. What's the slope in the fourth equation? 5. So for two parallel lines, for two lines to be parallel, they have to have the same slope. Which two equations have the same slope? First and last. So these, oops. Okay, I'm going to write parallel for the last time, and then from now on, you'll see me, instead of parallel, this is what I'm going to write. This is the symbol that I will write for parallel, is I actually draw two lines that are parallel to each other. This is me. Okay, you guys write the word, that doesn't matter to me. For me, I'm not going to keep writing parallel. So they are parallel to each other. It is, as long as you remember that word, okay? Because vocabulary is important, right? The first and last equations have a slope of 5, and thus they are parallel to each other. So whenever you're determining if the equation of the two lines are parallel, you have to look at the slope. Why? This is how bad this is? This is bad? Yes, she is. Okay, are you guys okay with this? All right. So let's look at the first question here. It says, write an equation that is parallel to each equation below. Okay, so let's do 1a, for example. Okay, so they want us to write an equation that is going to be parallel to the first equation here, y equals x plus 7. Give me an equation that's parallel to this.
Y equals 5 minus 8.
5?
Y equals x minus.
Okay, so x. So you see that your slope here is 1, right? So my equation is going to have the same slope, but your intercept could be anything. Your y-intercept could be minus 8, it could be 10, it could be plus 2, it could be plus 1. It could be anything as long as your slope is the same. Okay? I'm going to show you something here, okay? Let's look at this. So I have y equals x plus 7, yeah? All right, now, are you guys paying attention to this? So, Nancy, you gave me y equals x minus 8. Look at these two lines, right? No matter how high I go, right, they look like the railway track, right? The train track. No matter how far I go, they're never gonna touch. They're parallel to each other. Can you guys give me another equation that's parallel to this? Y equals what? Give me another equation.
Jennings is at the door.
Give me another equation. Y equals x. What do you mean by 2 over 2? X minus 20? Okay. But that's going to be far down, but that's fine. Okay, if I look at it, it's going to be right here. You see that? You see that? They're parallel to each other. Give me another equation. Y equals x plus 2. Okay? You see how all these lines are parallel? They're never going to meet. And the difference here is their y-intercept is different, but their slope is all the same. Their slope is 1 for all the equations. Okay? So for the answer for this, if you gave me x minus 8, if you gave me x minus 20, if you gave me x plus 2, the answer is correct. They all have the same slope.